Okay, welcome to lesson 2. Last time we talked about random variables, and we focused in on discrete random variables, and now we're going to focus in on a specific kind of discrete random variable, and it's called binomial random variables, and we're going to look at binomial distributions. So we're going to determine the probability of events modeled by binomial distributions. All right. There are certain conditions that have to be met in order for a particular situation to be considered a binomial or Bernoulli experiment. The first thing is you have to have only two outcomes. You have to at least be able to classify the outcomes to be success and failure. The success is not always the desirable characteristic, it's just the characteristic we're interested in. All right, so the features are there's a fixed number of trials, which we denote as N. The trials are independent and repeated under identical conditions. Each trial has only two outcomes, success denoted by S and failure denoted by F. For each individual trial, the probability of success is the same. Okay, the probability of success is P. The probability of failure is Q, and it's always equal to 1 minus P. The central problem is to find the probability of X successes out of N trials. All right, so remember, we're looking for repeated independent trials, a number of trials that's equal to N, success and failure, X number of successes, P is the probability of success, and 1 minus P is Q, and that's the probability of failure. So a marksman takes 8 shots at a target. All right, so we've got repeated independent trials, and there's 8 of them. He normally hits the target 70% of the time. Okay, so we've got a probability of something, and it's hitting the target. So hitting the target can be success, not hitting it can be failure. P is 0.7, so Q is 0.3. We want to find the probability that he hits the target exactly 6 times. Okay, so we know the probability that of the marksman hitting the target 1 time, but we want to know what's the probability that he hits the target exactly 6 times out of 8. So is this a binomial experiment? Let's check. So we have repeated independent trials. N is 8. Successes hits target. Failures doesn't hit target. Number of successes is 6. Probability of success on any individual time is 0.7. And the probability of failure is 0.3. Yay, we have a binomial experiment. All right, so here is our formula for finding binomial probabilities by hand. Luckily, our calculators will do this for us, but I think it's good for you to at least see this. All right, it's the probability of getting X successes out of N trials is going to be the number of combinations when you have N objects choosing X at a time, times the probability of success to the X power times the probability of Q to the N minus X. So it's P to the number of successes and Q to the number of failures. Remember, the number of combinations when you are picking X objects out of N objects is N factorial over X factorial times N minus X factorial. All right, so just as an aside, we're not back at the target problem right now, but just given N equals 6, P equals 0.1, we want to find the probability of 4. So that means the probability of having 4 successes out of N 6 trials when the probability of success is 0.1. Okay, so we're going to have N factorial, so 6 factorial, over X factorial, so 4 factorial, over N minus X factorial. So we've got our 6 minus 4, so that's 2 factorial. probability of success to the power of the number of probabilities, so 0.1 to 0.4. I mean, to the fourth power, because there's 4 successes. And then where did we get the 0.9? Remember, this is Q. It's the probability of failure. It's just 1 minus whatever P is. So 0.9. If there's 4 successes out of 6 trials, that means there's 2 failures, because 6 minus 4 is 2. All right, so we calculate all that, and we get 0.001215. It's not very likely. All right, let's look at our situation that we've been looking at. A marksman takes 8 shots at a target. He normally hits the target 70% of the time. Find the probability that he hits exactly 6 times. So N is 8, P is 0.7, and we want to find the probability of 6 successes. All right, so we use the same formula and we get 0.2964755. Remember, you get Q by doing 1 minus P. So 1 minus 0.7 is 0.3. This is X factorial, so 6 factorial. This is N minus X, so 8 minus 6 is 2. All right, so we can do this on our calculator. So that's probably how you're going to want to do it. So you're going to go, you can just be in the scratch pad. You want to go to menu. We're doing something with probability. We're working with a distribution, so choose that. And we want binomial PDF. There's a binomial CDF, and we'll talk about that in a minute. But for now, we want the PDF. X is going to be the number of successes, written as binomial, and then you're in parentheses, you're always going to put the number of trials, and then the probability of success and the number of successes. So for our situation, we would enter 8, 0.7, 6. And we get the same answer. Excuse me. Using binomial PDF, when we have n equals 8, p equals 0.25, we want to find the probability of 6 successes. And so we just re-enter and we get 0.004, and we're going to round to 3 decimal places. Another example. So suppose the probability that a certain treatment cures a patient is 0.30. So for any one patient, there's a 30% chance of getting cured. 12 randomly selected patients are given the treatment. Find the probability. Exactly 4 are cured, all 12 are cured, none are cured, and at least 6 are cured. All right, so for all of the problems, some of the things are going to stay the same. N is going to be 12. P is going to be 0.30. Q is going to be 0.70. What's going to change is X. So on this first one, X is 4. So when we do binomial PDF, we're going to put in the number of trials, so 12, the probability of success, so 0.3, and then the number of successes, 4. The calculator understands the rest, and it gives us our probability. All are cured. That means X is 12. We do the same thing. And rounding to 3 decimal places, it's 0. For none, X is 0. So we enter 12.30, and our probability is 0.014. Excuse me. At least 6 are cured. Okay, so let's think about that. So that would mean X equals 6, 7, 8, 9, 10, 11, or 12. Okay, we can go through and find out all the individual probabilities and add them up, or we can use something called binomial CDF. And so, like always, N's going to come first, and then P, the probability of success. But now we have a starting point and a stopping point. So 6 is our starting point, 12 is our ending value. And so we can just put that in the calculator and it gives us exactly what we want. That is so awesome. We can also find the mean and standard deviation of binomial distributions. It's easier actually than general random variables. The mean is n times p, and the standard deviation is the square root of n times p times q. All right, so for our situation with the marksman, our mean is going to be 8 times 0.7, so it's going to be 5.6. You don't want to round that. You want to put 5.6 because this is a theoretical value. And then sigma is going to be the square root of 8 times 0.7 times 0.3. So the square root of 1.68 is 1.3. All right, go ahead and do the problems to try on your own. If you need help, come find me. I hope you have a great day.